Hey everyone, so last class we were looking at position time graphs and how to graph the velocity and slope, all that on a position time graph. Today we are going to move on to acceleration. And so acceleration is related to velocity like we were talking about, but it's a little bit different. Acceleration is in fact the rate at which an object changes its velocity. So an object is accelerating if it is changing its velocity. So anytime you see a velocity increasing or decreasing, that means the object has an acceleration. So if an object is not changing its velocity, then the object is not accelerating. So let's take a look at this example here, example 1. So the data on the right shows an accelerating object because the velocity is changing with respect to time. So it's actually changing by a constant amount of 10 meters per second. 10 meters per second. That's it. So here if we look at our chart, at a time of 0, we have a velocity of 0 meters per second. So if you have no velocity, you're not going anywhere. At 1 second, we've moved our velocity to 10 meters per second. Then at 2 seconds, we've gone to 20. 3 seconds, we've gone to 30 meters per second, and so on. So you can see that we go from 0 to 10, which is an increase of 10 meters per second. And then we go from 10 to 20, which is again 10 meters per second difference. So we go 10, 20, 30, 40, 50. That's what it means by we're changing at a constant amount. So this would be a constant acceleration, okay, right here. Sometimes an object will change its velocity by the same amount each time. So like here, we increase by 10, increase by 10, increase by 10, increase by 10, increase by 10. And so that's what is referred to as a constant acceleration. So the velocity is changing by a constant amount. So that should not be confused with an object with a constant velocity. So if you were traveling at a velocity of 10 meters per second always, that would be a constant velocity. This would be a constant acceleration because you're increasing by the same amount of time. So I know that's a little bit confusing. We really have to wrap our heads around that idea that a constant velocity is different than a constant acceleration, okay? So we could also have a changing acceleration. So that would mean that the object is accelerating at different amounts per unit of time. So let's take a look down here. Example 2, so we'll look at our two charts here. This one, the object is changing its velocity by a constant amount each second. So we go from a velocity of 0 to 4 meters per second to 8 meters per second, 12 meters per second, 16 meters per second. So this would be a constant acceleration because our velocity is consistently increasing by 4 meters per second, right? If we wanted to look at a changing or non-constant acceleration, we can look here. So we're going from a velocity of 0 meters per second to 1 meter per second, then up to 4, then to 5, then to 7. So we changed by 1 meter per second in this interval, and then we changed by 3 meters per second here, then by 1 meter per second, and then by 2 meters per second. So here the velocity is constantly increasing by the same amount, which is 4. Here the velocity was constantly increasing, but by different numbers of velocity, by different accelerations, right? So we went from 0 to 1, then 1 to 4. That's different. So this is only an increase of 1 meter per second. This was an increase of 3 meters per second. So again, just to reiterate, a constant velocity would be traveling at 4 meters per second for an extended period of time. A constant acceleration is when you increase the velocity by the same value each time. And then a non-constant or changing acceleration is when you increase or decrease the velocity by a different amount each time. Okay, so that's a little bit confusing. Really look at these graphs and wrap your head around that idea of the difference between a constant velocity, constant acceleration, and non-constant or changing acceleration. So once you have that, we have a formula to calculate the acceleration of an object. So here it is here. Average acceleration is equal to the change in velocity divided by the change in time. So VF minus VI divided by time. And just remember that VF means final velocity and VI means initial. If saying velocity 1 for initial here and velocity 2 makes more sense to you, you could use that instead. Just use whatever wording makes the most sense to you for VF, VI, knowing that you're taking the ending product and then subtracting the starting product from that. Okay, so here's an example of how we could calculate acceleration. So we took the information that we had in example 1. So we've seen this chart before, and then we're going to take our equation and plug our numbers in here. Okay, so acceleration is equal to our final velocity minus our initial velocity divided by our time. Our final velocity on this graph is 50 meters per second, so that's why this 50 meters is here. The VI was a velocity of 0 meters per second, so we have 0 meters per second here. Time, we know that it's 5 seconds because we started at 0, but we have to make sure that not all graphs would start at a time of 0 potentially, so we just do our 5 seconds, our final time, subtract our starting time of 0 seconds. Okay? And then we divide this all out, and it ends up being 10 meters per second divided by 1 second. So these units are a little bit confusing, meters per second per second. So this is how the units of acceleration are written. Okay, so you have meters per second or meters per second squared. So to break that down, it says since acceleration is a velocity change over time, the units on acceleration are velocity units divided by time units. So velocity is equal to meters per second, time is equal to seconds. So these things don't cancel out. You end up with having meters per second, and you can also write that as meters per second squared. So this is my preferred way of writing it out. I just think it looks a little bit neater. If this makes way more sense to you and you want to write out meters per second, that's completely fine too. Whichever of these kind of forms makes more sense to you, write it out that way. Just know that when you're calculating acceleration, you have your velocity units divided by your time units, so you have to include them both. So it becomes meters per second or meters per second squared. Okay? So a negative acceleration, we're just going to talk about this quickly. This one's a little bit of a trickier concept, so really focus on this. So acceleration is negative in either of the following cases. So when an object is slowing down, that would be a negative acceleration. So say if we look up here and this graph was flipped and it went from 50, 40, 30, 20, 10, 0, that would mean we have a negative acceleration. The object is slowing down, so it's considered a negative acceleration. Okay, as well, when the object has a negative velocity, so it's moving in the negative direction. So we are going to talk a little bit more about negative accelerations later. Just kind of have that idea of if an object is slowing down, it's still an acceleration, it's just called a negative acceleration, okay? And then also anytime the object is traveling with a negative velocity, so moving to the left or moving downward, that would be a negative acceleration as well. So here is a couple practice questions for you, question A and question B. So I want you to calculate the acceleration for these two different motions, just to get some practice using this formula up here, okay? So read through these notes, do these practice questions, and if you have any questions, send me a message on Edmodo.